What if the universe isn't as predictable as we think? What if, in the vastness of space, our carefully written rules break down and something entirely unexpected appears? A planet, a world orbiting a distant star. Not just any planet, but one that challenges everything we thought we knew about how worlds are born. It shouldn't exist. Not according to the models, not according to the laws of planetary science, not according to the very foundations of physics that we've come to trust. And yet, it does. This is the story of a discovery that stunned astronomers. A planet too large, too close, too improbable. A planet that didn't just raise questions, it cracked open the door to entirely new ones. Questions about how planets form, about the stability of solar systems, about the nature of reality itself. You're about to go on a journey, not just through space, but through the mind-bending possibilities that arise when the universe stops playing by its own rules. From the tiniest particles to the architecture of galaxies, we build our understanding of the universe through structure. We categorize, we model, we simulate. But the universe doesn't follow our comfort zones. Every so often, we find something that reminds us we don't have all the answers. This story begins not with certainty, but with a mystery. An object was detected orbiting a star in a way no planet should. Some called it a mistake, others a fluke. But a few asked a different question. What if this isn't an error? What if it's a clue? Imagine building a puzzle, piece by piece, picture by picture. You think you understand what you're creating. Then a piece appears that doesn't fit the pattern. It's not broken, it's just different. That's what this planet is. Different, unlikely, and perhaps more important than we could have imagined. Because when something doesn't make sense, sometimes it means our map of reality needs to expand. This is not just a story about one strange world. It's a story about all of us, about our desire to explain the cosmos, about the limits of our understanding, and about the possibility that, out there, the universe is more chaotic, more beautiful, and more alive than we ever dreamed. Let's begin with the moment it all started, the discovery that changed everything. In a quiet observatory nestled beneath a clear sky, a group of astronomers scanned the cosmos like they had for decades. Night after night, they recorded light from distant stars, capturing data from thousands of light years away. Much of it seemed routine. Light curves, spectral shifts, minute variations in brightness, until something unusual appeared. A star dimmed, not briefly, not in the pattern of a planet transiting across it. This dimming was irregular, prolonged, and far too dramatic. It didn't behave like anything seen before. They double-checked their instruments, ran simulations, looked for calibration errors. But the data held. It wasn't just a glitch, it was real. Eventually, what emerged from the confusion was a planet, an enormous gas giant, orbiting far too close to its star. So close, in fact, that it should have been destroyed long ago by the heat and gravitational forces. It was an ultra-hot Jupiter-type exoplanet, but unlike any other. Most hot Jupiters are massive, yes, but they're predictable. They orbit their stars tightly and burn intensely. But this planet was even more extreme. Its orbit was chaotic, its atmosphere scorched to unimaginable temperatures, and its mass seemed inconsistent with how it should have formed. This world, according to our understanding, shouldn't have survived the formation of its own solar system. And yet, there it was. The planet was given a name, one long and technical, like all celestial discoveries. But behind the official title was a nickname whispered among the astronomy community: the Impossible Planet. To understand why this was such a shock, you have to understand how planets are believed to form. Planets are born in protoplanetary disks, vast spinning rings of gas and dust that surround young stars. Over time, these particles collide and stick together, forming clumps that grow larger and larger. Eventually, they become planets, but the process follows rules. Gravity pulls, heat pushes. Gas giants typically form far from their stars where ice can stabilize their mass. The planet in question violated these conditions. It was too big, too close, and orbiting in a configuration that made no sense. It hadn't been flung in from the outskirts. Its orbital data didn't support that. And it wasn't just a one-off event. Around the same time, other astronomers began finding similar outliers. Planets with retrograde orbits, moving opposite to their star's rotation. Planets that were tilted so far off axis, they spun like tops about to fall. Planets orbiting in trios, sharing paths that classical mechanics said should destabilize within years. One by one, these planets added fuel to a growing fire. Was our understanding of planetary science fundamentally flawed? The impossible planet became a symbol of scientific humility, of the fact that even in the age of powerful telescopes and advanced computer models, we are still students of the stars. The more they studied it, the more bizarre it became. The planet's composition didn't match any known formation path. Its atmosphere contained exotic molecules, some never before seen in any planetary atmosphere. It had intense magnetic storms, heat patterns that defied prediction, and a gravitational effect on its host star that hinted at some hidden mass nearby. Perhaps another planet, or something else entirely. Nothing made sense, and as word spread beyond the scientific community, the mystery deepened. Was this planet a fluke, an exception? Or was it the first in a long line of discoveries that would force us to rethink the universe? What if this wasn't a bug in the code? What if it was a message? What if this planet was showing us that our rules aren't universal, that the cosmos isn't bound by what we find comfortable or familiar? For the astronomers, the impossible planet was both a gift and a challenge. A gift because it opened a new chapter of exploration, and a challenge because it made one thing terrifyingly clear. We might not understand the universe nearly as well as we think. To understand how extraordinary this planet is, we have to revisit the very foundation of planetary science. For centuries, our models of planet formation have followed a clear, logical path, starting with dust and gas in a protoplanetary disk, and ending with well-behaved worlds orbiting in stable systems. But the impossible planet shattered that sense of order. According to accepted theory, gas giants form in the cold, outer regions of a solar system, where ice can condense and provide the solid core needed to attract gas. This process takes time, millions of years, and occurs at a distance where temperatures are low enough to allow such accumulation. Yet this planet had formed, or at least existed, much closer to its host star, in a region far too hot for ice or dust to coalesce. It wasn't slowly migrating inward after forming in the outer disk. Its orbit showed no signs of that history. It was simply there, right where it shouldn't be. This presented a serious problem for planetary science. If the accepted models couldn't explain this planet's existence, what else were we getting wrong?